For topic 3, we're going to look at finding the line of best fit. And secretly, we've actually already done the whole process. I was just focusing on the correlation coefficient. But if you can find a correlation coefficient, you kind of get the equation for free. So let's do a quick recap here. Linear regression is a method used to describe the relationship between two numerical variables, or two numerical values, I guess, variables. This process finds the equation for the line that best represents the data points, okay? The line is called the line of best fit or the regression line, and linear regression is used to make predictions about data sets and see if there's a positive or negative trend to that data. Again, real world data is rarely going to fall exactly on a line, but a lot of times we can have situations where data points hover very closely around a line. So we kind of get like a guesstimate for what the line that best represents that data set would be, and then we can use that equation to make some predictions or approximations about that data set. Okay. So we'll use the TI-84 calculator and Desmos just like we did for the scatter plots, just like we did for the correlation coefficient. It would be nice if I could do just one or the other, but some of you use the calculators, some of you use Desmos. So I'm going to show you how to do it on both, even though it takes a little bit longer. Okay? So you already know how to find the correlation coefficient. And again, if you can find the correlation coefficient, you can find the line of best fit. Now, there is one thing here that I should have added, but I just derped when I made my notes and I didn't. The form, well, that's not going to work. Let's do this. The format for the equation for the line of best fit is essentially y equals mx plus b, which you should already know that's kind of just the slope-intercept form of a line. However, on the calculator, you will see it as ax plus b, but it's going to mean the same thing. So a is the same thing as m, which is the slope. So don't be alarmed by that. But we are looking for an equation of the form y equals mx plus b, where we have a very obvious y-intercept and a very obvious slope. You will commonly, almost always, not always, but almost always have to round some values because a lot of times a and b are going to be decimals to many, many decimal places. So it is very common to represent your equation in the form y equals mx plus b. That's what we're looking for, but you're frequently going to have to round the slope and the y-intercept to like 2 or 3 decimal places. All right, so let's look at 2 examples. Again, I'm going to do them both on the calculator and then again on Desmos just to make sure we have shown enough for each group of students because I have about half and half. So half of you are using the calculator, half are using Desmos. Okay. So it says, for example, 3, the data in the table here below models the number of hours a student plays video games each week compared to their cumulative grade point average. Answer the questions rounding all values to 2 decimal places. Okay, so you can see here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students, it looks like. And the first column, the hours of video games per week, this is going to be X. Frequently, if you're dealing with a time component, that's going to be X, but in this case, I'm saying for sure it's X. And then the corresponding GPA is going to be Y. Okay. So it says use the data to find the correlation coefficient. That's part A. And then for part B, it says use the data to find the equation for the regression line. Okay. So let's do the calculator first for part A and B. Then we'll do Desmos for part A and B. And then we'll just answer part C independently. Okay. So let's do the calculator first. All right, so for the calculator, we've already turned our diagnostic on, which will calculate R. If you ever do this process and R is not there, it's because your diagnostic is not on. So you need to go through the process to turn your diagnostic on. The good news is once you turn it on, it should be there until you clear the memory on your calculator. Okay, so let's go to Stat. In that first menu, we want to choose option 1 for edit, and we're going to clear out the old junk. Okay. And then we're going to type in our data set, which is in front of me now. Okay. So our X values, we have 0, 0, 2, 3, 3, 5, 8, 8, 10, and 12. Now remember, the X values represent the number of hours these particular students play video games per week. Now we want to type in the corresponding Y values. So first we have 3.49, Then we have 3.05, 3.24, 2.82, 3.19, 2.78, 2.31, 2.54, 2.03, and 2.51. And then always double check and just make sure you typed everything in correctly. As soon as I get super confident and I'm like, oh yeah, I've got it, that's when I always make the typo. So just double check your work. So 0, 3.49, 0, 3.05, 2, 3.24, 3, 2.82, 3, 3.19, 5, 2.78, 8, 2.31, 8, 2.54, 10, 2.03, and 12. Yes. I think mine is good. So the first thing I'm going to do, you don't have to do this step. I just like to do this step. I'm going to tweak my window and look at my scatter plot just to get kind of a visual, like what is happening with this data. That way, when I see my correlation coefficient, I can be like, yeah, that makes sense or not. So for my window, my x's go anywhere from 0 to 12. So I'm going to do like maybe -5 to 15 incrementing by 1. That way I can see all of the data points and none of them are going to be like right on the border of my screen. And then my y values are 2.03 to 3.49. So let's just do like 0 to 5. Okay. So we'll do 0 to 5 for the y's, incrementing by 1. And there's our data points. So I would say that there is definitely a linear trend here. I would say it's a negative linear trend, meaning as X increases, as you increase the time on the video games, your GPA decreases. Okay, so there does seem to be a linear trend, and I would say it's a fairly strong negative linear trend. So we would expect R to be negative and pretty close to -1. Okay, so let's go back to stat. And remember, we want to go over to calc. And then we want to choose option 4, linreg for linear regression, but make sure you get AX plus B. Okay, so option 4, my X's are in L1, my Y's are in L2. So just hit enter, 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 and then it's going to calculate for us. So what it's doing here is it saying, hey, the format of our line is y equals ax plus b, okay? And then it tells us values for a and b. So a and b are these crazy decimals, so let's round to 2 decimal places. So I'm going to say a is -0.09 and b is 3.28, okay? And then don't worry about r squared. R is -0.87, okay? And that makes sense. We would expect from that scatter plot to have a negative value for R, and it should be pretty close to -1, and that's what we have here. We have -0.87. So let's go to the worksheet and type that or write that out before I forget. So we have a correlation coefficient of -0.87. Is that what I got? Yes. And then we're told that the format of our equation is y equals ax plus b. We are then told what a and b are, and we're going to round 2 decimal places. So I have -0.09, and then I have 3.28. So that's not enough. We want to actually fill these values here into that format of the equation. So we want to write out the actual equation. So I'm going to say y equals -0.09x plus 3.28. All right. And now let's do the same thing. I'm going to show you all how to do this again on Desmos. So I'm going to show you both. Even though it takes a little bit of time, I just want to make sure everybody sees their preferred method. So let's go to Desmos. Now remember, in Desmos, you have to tell it that you want to fill in a table. So we're going to go to the plus button and then table. And we're going to type in those X values again. So we had 0, 0, 2, 3, 3, 5, 8, 8, 10, and then 12. And then for the Y values, we had 3.49, 3.05, 3.24, 2.82, 3.19, 2.78, 2.31, 2.54, 2.03, and whoops, don't do that. And 2.51, double check to make sure you didn't make any stupid typos. So 0, 3.49, 0, 3.05. Okay, I think I've got mine typed in correctly. And what's kind of nice about Desmos is it just does everything all on one screen. So you can just click on the graph and then kind of grab it and pull. Okay, so you can see there is your scatter plot. Again, you can see that there's a negative linear trend here. Those data points do seem to be pretty compact about a line, meaning as x gets bigger, y gets smaller. So generally speaking, we can say that the more time you spend on video games, the lower your GPA is. That's not set in stone for everybody, but generally speaking, that is true. And so we can see these points are pretty compact about the line, meaning we would expect the correlation coefficient to be negative because the points are going downhill, meaning as x gets bigger, y gets smaller, and we could expect the correlation coefficient to be close to -1. Now, how on earth do we get the correlation coefficient? This is the weird part about Desmos. You want to type y1 or like y sub 1, so y underscore 1, that'll do the y with the subscript 1. Leave the subscript, so just hit the right arrow. And then you don't want to type in an equals. You want to do the weird like tilde. So looking at the regular just main keyboard, there's the 1 with the exclamation point. To the left of that is the tilde button. So you go shift the button to the left of 1, and then you want to type in your M, and then you want to type x sub 1. So x underscore 1. Leave the subscript and type in a plus b, and it gives you, not only does it give you the scatter plot, it also shows you the actual line graphed through your scatter plot, and then it gives you the information here. So we're saying, hey, we want our line in the form of y equals mx plus b. And it tells you in this case not what A is, but what M is. Remember, A equals M equals the slope. So we have here that M equals to 2 decimal places, -0.09, and then B is to 2 decimal places, 3.28, and R is -0.87. So we get the exact same information, plus the scatter plot, plus the actual line of best fit graphed through the scatter plot. Okay, so that is Desmos and the calculator. All right, let's go back to the worksheet. All right, now that we've got our correlation coefficient and our equation two different ways, let's look at part C. So part C says use the regression equation to predict the GPA of a student who plays 15 hours of video games per week. Now, just because a student plays video games 15 hours a week does not mean their GPA is going to be exactly what we get. We would say something like, we could expect a GPA of approximately blah if a student plays video games 15 hours per week. Now remember, this right here is time, which is x, and the GPA is y. Okay, so we have y equals -0.09 times x, which would be 15 in this case, plus 3.28. And I'm going to use just the maybe I'm not, yeah, I am. I'm going to use just the handheld calculator to do this part. So I'm going to take -0.09 times 15, and I get -1.35 plus 3.28. And I get y equals 1.93. Now, don't stop here. Like, explain your answer. Say, we could expect a GPA of approximately 1.93. That does not mean if a student plays video games 15 hours, they're going to have a GPA of exactly 1.93. But given the trend that we're seeing here, we could expect something like that. Okay, let's look at example 4, and then we're done with everything for the whole course, which is like kind of happy and kind of sad. Maybe for you all happier than sad. For me, either way. All right, so example 4, it says the data in the table represents the weight in grams of various candy bars and the corresponding number of calories. So does the weight have anything to do with the calories? For example, as the weight increases, does that mean the calories also increase? That would kind of make sense. A heavier, denser, bigger candy bar would seem to have more calories than a smaller, lighter candy bar, right? So we're going to answer the questions rounding all values to 2 decimal places, okay? So we have the candy bars listed, and then we have their weight and their calorie count. Let's say weight is X, calories Y. Okay, so let's go to the calculator. Let's do the calculator first, just to be consistent. So I want to go to Stat, Edit. I'm going to clear out the old junk. And we're going to type our data values in. So for the L1, I'm going to put my X values, which are 44.28, 44.84, 61.3, 47.33, 58, 61.12, 39.52. I'm going to double check to make sure I don't have any typos. So 44.28, 44.84, 61.3, 60. Ooh, I forgot one. So don't be like me. After 61.3, we had 66.45, 47.33, 58, 61.12, 39.52. This is exactly why you always check yourself. You get too confident and skip one. So 44.28, 44.84, 61.3, 66.45, 47.33. See, I did it again. 58, 61.12, and 39.52. All right, now let's do the Y's. We have 230. Ah, jeepers. Dang it. Son of a gun, I'm gonna have to just start over. Some days you're winning and other days you just can't catch a break. Okay, we're gonna do this and we're gonna get it this time. So we have 44.28. 44.84, 61.3, 66.45, 47.33, 58, 61.12, 39.52. Good Lord, hopefully that did it. All right, so now we need to type in the calories. So 230, 230, 270, 280, 220, 280, 280, and 210. Okay, quadruple check your numbers because if you type like I type, you have to do it 46 times. Okay, so I think we're good. Let's go ahead and look at our scatter plot. We're definitely going to have to tweak our window. So looking at our X's, we have X's that are anywhere from 39.5 to 67. So let's say we go 25 to 75 maybe. And let's increment by maybe 5. And then for the Y values, we have Y's as low as 210 and as high as 280. So let's do like 200 to maybe 300. And let's increment by like, I don't know, 10. And there you have it. You can see there does appear to be some kind of positive linear trend. It seems as X gets bigger, Y also gets bigger. So we would expect R to be positive. And these points seem to be hovering pretty closely around a line. So I would expect R to also be pretty close to 1. Okay. So we've got our data in. Let's just go ahead and do the calculation. So let's go over to calculate. So hit stat and then go over to calc. We want to choose option 4, ln reg AX plus B. Make sure you got your L1, your L2 correct. Hit enter. And we have the format y equals ax plus b, and we are told that a is 2 point, let's go 2 decimal places, so 2.88, and b is 97 point, let's go 57, and then r is 0.95. It makes sense that r would be positive because the line was going uphill, there's a positive trend, and it would also make sense that r is pretty close to 1, okay? So let me make sure I've got this written down. I do. Let's go to the worksheet really quick. Okay, so R was 0.95 to 2 decimal places. And then remember, we're looking at y equals ax plus b, and we are told that a is 2.88 to 2 decimal places, and b was 97.57 to 2 decimal places, okay? So when we write this, we want to write out the actual equation. So I want to see y equals 2.88x plus 97.57. All right. Now let's go to Desmos and make sure that Desmos agrees, and Lord willing, I'll be able to type it in better this time. All right, so let's go to Desmos. We can clear out the old junk. Well, let's clear out the table. All right, so we want to go to the plus sign and table. And this time we had X values of 44.28, 44.84, 61.3, 66.45, 58. Whoops, I forgot 47.33, 58, 61.12, 39.52. Okay, it is important that you type these in the order they appear in the table because remember for each X it has a very specific corresponding Y, so you can't like change the order unless you change the order of the Y too. So I just type them in the order from the table. So let's double check and make sure I didn't screw this one up. So 44.28, 44.84, 61.3, 66.45, 47.33, 58, 61.12. I think that's good. Well, let's type in the calories. So 230, 230, 270, 280, 220, 280, 280, and 210. Let's make sure we're good there. All right. And notice you don't see the scatter plot because these points are like way beyond where we're at. So I'll show you how you can tweak the window in Desmos in just a second. For now, let's type in the weird y sub 1, leave the subscript, the weird tilde, m x sub 1, leave the weird subscript, and then go plus b. And we can see here that m, the slope, which is the same thing as a on the TI calculator, is 2.88. And the y-intercept, which is b, is 97.5. Ooh, this one says 97.59. Did I type that in wrong? Let me go back to the calculator really quick. Yeah, it should be 97.59. I don't know why I said 97.57. So 97.59. So we get 97.59 here, and then we get R is 0.95. So everything matches up. What I want to show you now is how you can tweak your window in Zoom, okay? This little wrench in the upper right-hand corner of the Zoom screen, you want to click on that, and it's got your x-axis and your y-axis, and you can tell it exactly where you want to stop and start. So let's say we go 25 to 75 for the x's, and then the step will tell you how it's going to increment. So let's just go by fives. And then on the y-axis, I think we wanted to go, was it 200 to 300, I think is what we did. And we incremented by 10. And then once you do that, you can see your scatter plot now. And then you can still zoom in or out, and then you can grab and scroll wherever you want. But there you can see your scatter plot with your line of best fit, and then you've got your equation over here on the left. So there you have it. Let's go back to the worksheet. We've got one more question to answer. Now, there is a potentially gigantic typo if you have the printed set of notes. I was copying and pasting and just forgot to fix something. So you might have part C be the same as part C for the previous example. What part C should say here is use the regression equation to predict how many calories a candy bar that weighs 50 grams might have. So we want this to be, remember, that's our x. So we have y equals 2.88 times 50 plus 97.59. Remember, this was actually 97.59. That was my own dirt. Okay. So using just the handheld, we get 2.88 times 50. So that's 144 plus 97.59. And I get y equals 241.59. So I would say approximately 242 calories. Now, generally speaking, we want to describe our answers at least a little bit. This is not set in stone. This does not mean if a candy bar has exactly 50 grams in weight, it's going to have exactly 242 calories. The filling in candy bars varies greatly. Like you could have like the lighter, fluffier nougat in like a Three Musketeer, or you could have the heavier caramel with like a bunch of peanuts like a Snickers. Okay, they may not be comparable calories. Who knows? But we would want to say something like, if a candy bar, you can tell it's late at night. If a candy bar weighs 50 grams, we could expect approximately 242 calories. Again, that doesn't mean we're going to get exactly 242 calories. We just know that 242 calories is a fairly reasonable estimate given the data that we have. Okay, so that is linear regression. I hope I've been fair to everybody. I would prefer to just show you one method, either just the calculator or just Desmos, but we have a good split of students using both, so I wanted to make sure I showed you both methods. I know it took a little bit longer, but Now you know two ways to do this. So there you have it. That's linear regression. Okay. That's it for the whole course. So if you've made it to this point, pat yourself on the back. You've made it. Now you just got to review and take the final exam, but you've made it through the content. All right. So that's it. It's been real. Best of luck to you.